Welcome to lecture number 22, chapter 4, cluster 1. Alright, so we are looking at polynomials. And a polynomial is an expression with many terms. Okay, so a way to kind of remember this, nomial would be kind of like number or term, and poly is many, like polytheism, many gods, or polygamous, many wives or marriages. Alright, so example 1, create a few examples of a polynomial. If you want to, you could pause the video and try to think of a few yourself, but I'll go ahead and create a few and let you know the names that we have for these. So there's one type. This would be a one-term polynomial. Okay, or we would call it a monomial. Nomial, once again, kind of meaning number, and meaning one. Like a monocle. You know, a monocle, that little one glasses piece that a person wears on their eye? Alright, so that's a monomial, or monomial. The next one we might have would be, let's see, 2x squared. I'll go ahead and tack on another term. Okay, notice, to create another term, we do the plus sign, or you can do a subtraction sign. And then, there we go. So now I have two terms. This is called a binomial. Once again, we have that term nomial for like number. And then bi, think of bicycle, the two wheels on a bicycle. That's my version of a bike right there. Alright, so binomial, two terms. Let's see. Let's go ahead and tack on another term. How about 4x? What would this be called? This would be called a trinomial. Once again, nomial for number, but tri for three, like maybe a tricycle. Alright, and you might wonder, well, what if we have something that has even more terms than 3? What would we call it? Well, once it's past 3, basically, you just say a polynomial with blank many terms. For example, if we had this polynomial right here, there are 4 terms, I would just call this a polynomial with 4 terms. So once it hits past 3, once again, we don't really have a name for it. It's not a quadnomial or something like that. I don't know why, but that seems to be what mathematicians before me have decided. Okay, let's go ahead and see this new term. So, a term in a polynomial is a party of expression separated by a plus or a minus sign, which we saw above. So, for example, if you're trying to figure out how many terms, you just look at the things that are being separated by a plus or minus. We have 2 items being separated by a plus or minus, which is why we have a binomial. For this one, we had 1, 2, 3 items being separated by, in this case, it was just pluses, which is why we called it a trinomial. Alright, so for example 2, we're going to determine the number of terms there are in each given polynomial. Okay, go ahead, pause the video, and try and name these and determine how many terms there are in each. Okay, so let's take a look. Well, this one, there is no plus or minus, it's just this one term. So this would be a monomial. So one term, monomial. The second one, we have that minus sign, which gives us those 2 terms, 4x and 10. This is 2 terms, hence it is a binomial. And for C, let's see, we've got minus, minus, and minus, plus, and minus. But that minus right here, that's actually just a negative sign. It's not separating any terms. So really, we just have this 4xy cubed term, 2y cubed, the 2y term, and the 3. Which means we only have 3 terms here, which is going to make this, so 3 terms. It's going to make this a trinomial. These are 3 more popular ones we tend to work with, I think, which is why they have names. Alright, moving along. So the degree of a polynomial is based on the highest power of a term in the polynomial. For example 3, determine the degree of the given polynomials. So what we're going to do is look at all the terms, see which one has the highest degree, and then that will be the term of our polynomial. So let's see, the first one, example A, has 1, 2, 3, 4 terms. What are the degrees of the term? Well, this one, that's a degree 3. This is the degree 2. That's a degree 1. This one, well, that's technically an x to the 0 power. That's a degree 0. So which term has the highest power? Well, the first one. What is the power? The power is a 3. So this is going to be a degree 3 polynomial. And B, let's take a look at B. Now this one's tricky because it actually has multiple variables that have different powers. So what you do with this is kind of interesting, is you take the addition of the powers. So we have a 2 and a 1, so this is actually a degree 3 polynomial. Okay, because we're looking at the degrees of the x and the y together. This one has a 3 and a 1, so that is a degree 4 term. This one just has a 1, so that's a degree 1 term. Which means this term in the middle is actually the one with the highest degree. So our polynomial here is going to be a degree 4 polynomial. Alright, let's keep going. Example 4. Simplify the following polynomial expressions. Okay, so when we're talking about simplifying, we're not solving anything. There's no equation going on here. Notice there are no equal signs equaling a number. So all we're going to do is probably the distribution property and the combining like terms. So I see the parentheses in example A, so I'm going to go ahead and distribute that too. Then I'll just rewrite this at 3x plus, well, 2 times 5x is 10x. 2 times negative 4x is negative 8. We can go ahead and combine the 3x and the 10x. And we get 13x minus 8 is our answer. For B, if you want to pause the video and try that out by yourself, go ahead. So I see the parentheses, so I'm going to go ahead and get rid of those first. So distribute that 3. That'll be 3 times 2, so 6. Minus, then it's 3 times negative x squared, so 3x squared. Then we have the negative 4, remember that negative, that's very important to remember, being multiplied out in the distribution property. So negative 4 times negative 4 times positive 2x squared, negative 8x squared, and then negative 4 times the 1 is going to be negative 4. Now, can we combine any like terms? Well, we have the 6 and the negative 4. And then we have the negative 3x squared and the negative 8x squared. So combining the x squared terms, we get 11, negative 11x squared. Combining the regular number terms, we get 2. Similar to what we've worked with before. Example 5, do as indicated. So these are just like much larger, bigger versions of the ones we've done before. So if you want to pause the video and work on it by yourself, you can. Let's see, got to get rid of any parentheses. This one, there's just a positive, so I can actually just drop those parentheses. For this one, though, there's that negative. So before I can drop the parentheses, I got to distribute the negative. So then I have 7x squared. I'm just writing the first grouping without the parentheses. And then, so negative times negative 4 is going to be positive 4x squared. Then we get positive 3x, and then a minus 20. So let's go ahead and combine the terms. Got the x squared there. I normally work my way down using the highest terms, so I look for the highest powers. So that's 11x squared. Now let's look for the next highest power. That's just going to be the x terms. So I have a 12x and a 3x. That's going to be 15x. And then I have a negative 9 and a negative 20, which is going to be negative 29. Ooh, and what's this? This is a trinomial. With what degree? Degree 2. That's just for fun. Okay, let's look at B. Once again, I'm going to get rid of all the parentheses. The first one, Doesn't have anything to distribute, so I'll just drop those parentheses. Second one also, that's just a plus sign, so I'll go ahead and just drop their parentheses as well. And the last one also, no negative sign, so really I can just drop the parentheses on all of them. I'm going to go ahead and start with the highest power number I see, which is going to be the 5 cubed. That one does not have any matching terms, so I'll just go ahead and write him down first by himself. Sort of lonely. Next highest power is a squared, so I have one of those, and that's it. So x squared minus 9 squared is going to be negative 8x squared. Now let's go for the x terms. I have 1x, 2x, 3. So adding those up, let's see, those ones would cancel each other out, so we're just left with the 2x. And lastly, we have the regular numbers. So negative 7 and negative 3 is going to be negative 10. And there we have it. We are done. All right, let's keep moving along. Example 6. Simplify the functions as indicated. All right, so we're given this function. If f of x equals 3x squared plus 2x minus 1, find f of 4. So we're going to be replacing x, swapping that out with 4. So I want f of, what did I say, 4? So wherever I see x, I'm going to be replacing it with 4. We'll get 3 times 4 squared plus 2 times 4 minus 1. Simplifying, that's going to be 3 times, well, 4 squared is 16. Plus 2 times 4 is 8 minus 1. 3 times 16, that is going to be 48, I think. Okay, and then plus 8 minus 1, so that's going to be plus 7. So then 48 plus 7, let's see, what's that going to be? 55. So f of 4 equals 55. Please remember to box that whole function notation there. All right, last problem. If g of n equals 4n cubed plus 5, find g of 10. Same idea, we're going to be plugging in 10 wherever we see n. Oops, wrong pen. So g of 10 equals 4 times 10 cubed plus 5. G of 10. Ooh, that was an ugly G. Okay. G of 10 is going to equal 4 times 10 cubed, which is 1,000, plus 5. G of 10 equals 4,000 plus 5. Simplifying even further, G of 10 equals 4,005. A nice check there. All right. We can box our answer. Okay, so notice there are two different ways I showed my work between these two problems. The first one, I had the G of 10 following the entire way along on that left-hand side. The second one, or the first actually, the one above, I had this little arrow at the end from the top to the bottom. So depending on your professor, some of them will want you to carry the G of 10 or the function notation the entire way along. Others, I had one when I was in college myself, would allow you to just draw the line down to the bottom. Up to you. I will accept either version. Just know, though, if you continue on in math, some professors prefer this method, as this is the more proper method for showing your work. All right, that is it for Chapter 4, Cluster 1.